yoga day and bring some healthy habits into your life. And let's see some problems today. So here we go with the first problem. Let p of x is x5 plus something x4 plus something x cube, something x square plus something x plus a naught, where each a k is a complex number and the mod ak is less than equal to 6. So prove that if alpha is a complex number satisfying p alpha 0, which means alpha is a root, we have to show that the magnitude of the root of this equation will be less than 7. Okay, so let's start with the very fundamental idea of what root is. The root will definitely satisfy the equation that forces p alpha to be 0. a4 alpha 4 plus a3 alpha cube, a2 alpha square plus a1 alpha plus a0. So now if I'll take mod on both sides, I'm going to use triangle inequality. So you know from triangle inequality of complex number, if we have two complex numbers z1 plus z2, that will be lesser than or equal to the magnitude of complex number z1 and z2. This is direct consequence of triangle inequality. So from there we can tell it's less than mod a4 alpha 4 plus mod a3 mod alpha cube plus mod a2 mod alpha square and so on and so forth plus mod a naught, where I have used the property of mod z to the power n is mod z whole to the power n. Right? Now we know since all these ai's are less than equal to 6, so it will be definitely less than equal to 6 times of alpha 4 mod alpha cube mod alpha 2 mod alpha plus 1. Now we can see x4 plus x cube plus x square plus x plus 1 is a standard GP. So that evaluates to mod x5 minus 1 by mod alpha minus 1. So far so good. We found mod alpha to the power 5 is lesser than equal to 6 times of this result. Right? So now we can take two cases. Okay, if I'll cross multiply, so either mod alpha will be greater than 1 or mod alpha will be less than 1 or mod alpha is 1. We are not allowing mod alpha 1 here over here because if I'll take mod alpha is 1, then definitely mod alpha is less than 7, so that will take care of. Okay, so if I'll take mod alpha as 1, what we'll get is 1 is lesser than equal to, as you can see, it will be 6 times of 1, 2, 3, 4, 5, 30. So this is also correct, right? So in this step I can allow mod alpha to be 1, but not in this step, because this formula is valid if and only if mod alpha is not equal to, right? So now let's take two cases, because directly if I cross multiply I'll get wrong result. That depends on whether mod alpha minus 1 is positive or negative. So case 1, when mod alpha is more than 1. Okay, so under this case I can cross multiply, so we'll get mod alpha to the power 5 to mod alpha minus 1 lesser than equal to 6 mod alpha to the power 5 minus 6, right? And we know 6 times of mod alpha 5 minus 6 will definitely be lesser than equal to 6 times of mod alpha 5, because we are subtracting something out of it. So from this we can is lesser than 6, which evaluates to mod alpha is less than 7. Now what about the other case when mod alpha is lesser than 1? If mod alpha is lesser than 1, clearly it implies mod alpha is lesser than 7. So this is by default it implies this, so we are not going to consider this. So in general what I have shown is mod alpha is less than 7 for all the cases. So it was a good problem based on triangle inequality and how equations is connected with this. Let's try another problem, and this is from arithmetic progression. Now this is not a difficult one because this kind of problem often comes in JEE as well. So यहाँ से we can clearly see the 98 and we have T13, which is let's say A plus 12D, that's equals 89, and A is already 98. So यहाँ से immediately we can find the common difference to be, in this gives common difference to be minus 3 by 4. So I have a general term Tn, which is 98 minus 3 by 4 times n minus 1. So once I know Tn, capital Tn will be 7 times 98 minus 3 by 4 times n minus 1 plus n. So this is also in AP, plus n plus 5, right? And if I'll just add it up, So we are getting over here 7 times 98 minus 3 by 4, and that gives 7 plus 14, which evaluates to 7 over 4, 386 minus 3. This itself is arithmetic progression, and it has common difference of, as you can see, it is minus 21 by 4, right? So this has common difference of minus 21 by 4. And we are looking for the term nearest to 0. So we find T188. So you make it 0. So we'll get T188 is going to be 7 by 2. Because if when I'll keep 0, I'll get the value of n is 36 by 3, which is 128 point something, right? So we have to check for the term T128 and 129. So 128 is going to be 7 by 2 and 129 is minus 7 by 4. So according to question, we have to find magnitude of twin. So the minimum value occurs. Minimum value is 7 by 4, and which occurs at n equals 129. So this was the basic one. Like, since first question was of advanced level, so second I took mains. Now you can try the third one as well. Now this is from class 12 limit as integration of sum. So I know this can be decoded with in an integration fashion. We can take 1 by n common, so we'll get 1 plus k by n times c, and this sigma k is running from 1 to n, right? When I convert this into integral, it's a well-known result. So 1 by n will be replaced with dx, k by n will be replaced with x. So we have dx by 1 plus cx. In the limit of integration, you know, x will go to k by n. So when k is 1 by n tends to infinity, it will go to 0. So lower limit is 0. Upper limit when k is going to be n, so x will be limit n tends to infinity n by n, so that's 1. According to the problem, this should be equals ln 1 plus c over c. C gets cancelled if c is not equal to 0. Clearly we can't allow c to be 0. So it's possible if and only if 1 plus c equals e. It's a value of c, e minus 1. See, the only positive real number which satisfies this equation is e minus 1. So I hope you have enjoyed the sessions. If you want further problem solving of quality level, you can join my course, the WhatsApp link given. Thank you. Have a good day.